Graphing polynomial functions with odd degree. So we have a polynomial function here. F of x is equal to 2 minus x square, x plus 1 square, x minus 4 cubic. We are looking first of all for the leading coefficient. In this first binomial we have a minus x. Is a minus in front of the variable, but because it's the even degree, the leading coefficient is going to be positive. And here variable is positive, so leading coefficient is a positive. And the third one, leading coefficient is positive. So it means the leading coefficient is positive and the degree is odd. 3 plus 2 is 5 plus 2 is 7. So the degree is odd and the leading coefficient is positive. And let's go here and let's check with the leading coefficient test. It means if the degree is odd and the leading coefficient is positive greater than 0, then on the left side the endpoint falls and on the right side rises. So it means it falls on the left side and the right side rises, the endpoints. But here, first of all, let's take here what is the x-intercept. X-intercept, because those are opposite signs, x-intercept is going to be equal to 2. And the second, because both of them have the same sign, so the intercept is minus 1. And in the last one, x is that they have a opposite sides, so the variable and the constant here, so x is going to be equal to 4. Those are the x-intercepts. Or in other way, we can equate 2 minus x by 0. When you solve for x, x is going to be equal to 2 if you want a little bit in the longer way and more secure. And here, let's say x is minus 1, the x-intercept minus 1. Let's say minus 1 is here. And we have x is equal to 2 and 4. Let's say 2 is here somewhere. And let's say 4 is, let plot, or let just take this is a 4 arbitrary, but it's not in scale, but this is going to be the 4. So as we see on the right side rises the graph of the function, and on the left side it's falling down. And now we are trying to sketch the points. But before I go to this intercept, I'm going to look at minus 1. 2 minus 1 is the multiplicity 2. So there are 2 zeros. Whenever it's even, the graph of the function is not going to intercept. It's going just to touch the point, and it bounces down. And then doesn't matter how far it goes, again it has to go up. And I'm looking now for the intercept 2. And the intercept 2 is even. Again, this function here, the graph of the function, is not going to intercept, but it's just touching and goes down. And regardless how far it goes down, again has to go back to the intercept here 4. But 4 is multiplicity 3, because it's in 3 degree, multiplicity of zeros is 3. There are 3 zeros, and it means it's a little bit flat here. And then I'm going to connect those points here and the point at the end, and this is the graph of the function. So we already sketched the graph of the function f of x is equal to 2 minus x squared, x plus 1 squared, and x minus 4 cubic. So now we are looking for a polynomial function in the factor form here, and let me see, the degree is 2 plus 2, 4 plus 3, 7. So this is an odd degree. But if we are looking here in the odd, this is a minus here. So we already know this is, the leading coefficient here is going to be minus. So the leading coefficient is a minus. And in this one is a positive, here is a positive. Negative times positive is negative, negative times positive is negative. So leading coefficient is going to be negative. And because the leading coefficient is negative, an, or leading coefficient, is smaller than 0. And if we are looking at the leading coefficient test, with the odd degree, with the polynomial function in the odd degree, and the leading coefficient is smaller than 0, what we have here, on the left side it rises, and on the right side it falls down. So the endpoints of the function are going to be on the right side is going up, and the left side going down. This is the end behavior. So we can check one more time. So we already have here. And now we are going to find those x-intercept. And the first factor x-intercept is equal to 1. Let me go in the second one. Second one is x is equal to minus 2. The x-intercept. And I'm going for the third factor. The third factor x is going to be equal to 2. And those points we are going to plot in the Cartesian system. Now, minus 2, let's say, is here somewhere. And let's say 1 is here. And 2 is here. So I am spreading a little bit further because it's going to look the graph a little bit better. And how is going here the end behavior? And behavior already we see is in this way. And down here is going to go down on the right side. And the function has to go this way, has to connect the endpoint, but again, to minus 2 has to intercept. We are looking to minus 2. To minus 2 is even. So because it's even, the graph of the function goes down and is going to touch this point here, and then is going up, and is going to have somewhere x-intercept, y-intercept, I'm sorry, but has intercept at 1. We are looking at 1 for the multiplicity of zeros, how much is. And here is odd. Because it's odd, here is going to intercept here. But is a flat a little bit because the multiplicity of zeros is greater than 1. And now I'm going to connect to those points. So those points are going to connect. And it's going down. But again, this has to go to the intercept 2 here. So let me write this better here. Just let's look better. It's a flat a little bit here. And is going to go back again to 2. But to 2 we see is even multiplicity. When it's even, it's just going to touch it here and the bounces back at the graph of the function. And now it's just going here and bounces down. And it connects with the end behavior here. So this is a graph of the function. F of x is equal to 1 minus x cubic times x plus 2 squared plus times x minus 2 squared.